Hello, so welcome everybody to this OpenDaylight mini summit. My name is Luis Gomez. I'm actually a contributor committer of the integration group in OpenDaylight. I'm also part of the TSC and part of the board in OpenDaylight. And today we are here to present you will see for the first time some of the performance results for the OpenDaylight. I'm going to do a short introduction how we do test in OpenDaylight, and then I'll hand over to my colleague here, Marcus. You can introduce yourself as well.
Hi, my name is Marcus Williams. I'm a network engineer at Intel. I'm on our SDN team. I work with the integration test group as well as a contributor, and I'm a committer on CPerf for OPNFV, which is controller performance testing group. That's me.
I'm going to adjust this, hold on a little bit. I'm going to see this because otherwise it's too small, so I cannot really, or actually, you know what? Let's do like this. I'm going to, presentation mode, and then you can swap here and I can explain on the, okay. That's better. Because that way I can see what's going on. Oh, actually, I don't know if I can see well. It's not like we can see very well. Yeah, the problem is here, I don't know if I can zoom in. Phil, how do you deal with this? How do you deal with this tool? In the Mac. I know my slide, but the only thing is I don't know if the numbers are going to show later somehow. Yeah, maybe they do. That's okay. Yeah, that's fine. Yeah, I think I'm okay. Okay, let's get started. This is just... So, yeah, a little bit of test story in OpenDaylight. So the first thing was, I don't know, unfortunately we cannot see very well, but in September 2013, as you can see there, we created something called the integration group in OpenDaylight. This was we created with the scope of doing distribution, assembly, like we need to put all the projects together. At that time there were very few projects, along with doing some system tests. So we created a distribution and then we do some system tests around that. That was the first milestone or first achievement regarding tests in OpenDaylight. The second thing that happened in this timeline is the hydrogen release. That was in February 2014. And as you can see there, in that first release of OpenDaylight, we managed to get some system tests in for OpenFlow, BTN, some applications that were there. And that was all. I remember 2 years ago, I was in this same ONS, and then some people presenting OpenDaylight for the first time, and then some people asked for performance number. At that time, obviously, we didn't have any performance number. And we said clearly that we will use future releases to do performance tests. The next was Helium release. That was around September 2014. And that was the moment that we introduced the first performance test. The first performance test we did the known C-bench test. It was kind of standardized test for OpenFlow. Like there was an open source tool from Flatlight people. And then this tool was actually injecting a lot of packaging, and then you measure the throughput in the southbound, and that was the kind of test we have.
Yeah, you measure the flow mods from the controller, and they're just dropping all packets.
Yeah. And then that was the only test we got at that time. Lithium release was actually the release where we got a lot more of the tests, what we called SSP. SSP in OpenDaylight was a term that we introduced at that time. And it's the meaning of that, and you know very well.
S3P is actually it's scalability, stability, security, and performance, yes.
Yeah. So Lithium release was the first release we introduced this SSP kind of test. At that time, we did only for OpenFlow. So we got the OpenFlow plugin, and then let's do a scalability test, let's do performance test, all the way we know. And then do some scalability stability tests as well. So we did all that for the OpenFlow. And then Lithium release was also the first time we saw a cluster test in OpenDaylight. Very simple cluster test, only for data replication, but we got that in Lithium release. Finally, Beryllium release, this is the point, the first release, we actually gonna publish performance number. OpenDaylight, for the first time, we're gonna publish performance number. And some of this number you will see through this presentation, okay? So let's talk a little bit about tests in OpenDaylight in general, not just the performance number. So these are today all the different type of tests we have in OpenDaylight. As you can see here, these are all also important to know. You cannot see the title, but this is continuous integration test kind of test. And what is the difference between continuous integration and not continuous integration? Continuous integration means that all these tests are happening in real time. So whenever there is a new build, whenever we have a new merge in the system, there is a full strategy here. You launch this test, and then you make sure there is no regression, things are working normal. So what kind of tests we have today? We have build tests, as every software development project. You have build tests running at build time, JUnit, because you use Java. And then we have something called single feature test, that you test your feature is still available when you do changes in your code. The second is the one that I mentioned before, the one we did is initially in integration group and now is handed over to projects, which is called the system test. And this is to test features, but also multi-feature. So we bring a feature, we test it like a black box system test. And then we also bring multi-feature. We many features together, and we test the same feature and see there is no problem, there is no interference. The next one is what we talked about, the scalability, stability, scalability, and performance test. Whatever you see there, that was introduced in Lithium, and we do that in continuous integration. And we do, the last one was the cluster test, data consistency and high availability. Those tests we do as well. These tests are all available, so I will explain that later here. Here is a little bit how the strategy for the test works in OpenDaylight. And as you can see here, you have all kind of triggers. We'll go very quickly. When you have code submit, someone put a new patch in the system, you have a verified build that run all the build tests. And after that, we do distribution check. The distribution is not broken. And we do auto-release test. The release is not broken either. All these things are happening in real time when you push a patch in the system. Now, when a committer merge a patch in the system, there is many more tests happening. Like you see here, there is, again, a build test. But there is also a distribution build. And then after you build the distribution, you get feature tests, you get cluster tests, and you also trigger a bunch of tests in the downstream. Because we have a dependency change in OpenDaylight. When there is a change in the upstream, you trigger also tests in the downstream to make sure you don't break anything. And finally, you see for auto-release, we also do feature tests, we do multi-feature tests. Every time there is a new release or temporary release, we do all this, and we do cluster tests. And then we have daily triggers as well. So we kind of run tests periodically. These tests take longer, obviously, and that's why we don't trigger them very often, but still daily. And these are the stability, what we said before, the SSP test, and also the multi-feature test. These are longer tests that are periodic. Now, all these results that you see here, they are all available. So this is all the point here. You can see these are the link for the different places where you can see all these results. And for all that is performance, we plot this kind of graph, so you can go there and actually see all these results. It's all available. So now let's move to the Beryllium performance report. So the important thing to say about this report for the first time is that, first of all, is the way of performance report we did is based on real network test scenarios. So instead of using just artificial tools, internal kind of stuff to measure the controller throughput, we try to use real devices, or at least simulation of real devices, and all is external. So we try to do kind of system tests here, nothing like running internally. That is all the tests is more or less happening external to OpenDaylight. We use uniform and dedicated test environment. In the continuous integration, we use VMs. These VMs get spanned every time and so on, and that makes some kind of dynamic environment, and you don't know very well. So for this kind of performance test, we use really dedicated machines and kind of uniform specs. Another thing to mention is that we use more than one environment, actually two environments.
Yeah, we use two separate environments. They both are based on hardware environments. One has a lot more RAM than the other has, and one has a different number of CPUs. We just wanted to make sure that we had two independently reproducible sets of data that tell a similar story, so that we could make sure that what the numbers we're getting, other people could get.
Yeah. We also document, this is also very important. Whenever you do a performance test, you need to document very well, step by step, how you do your performance test. And the reason is that you see some vendors, in general in the industry, that they publish some result, but then you don't know how actually they got to that result, what was the condition, what were the steps. So difficult to reproduce. In our case, it was very clear that we wanted to do this very, the first thing we did actually is to document very well the test process, so anybody can do actually replicate this environment. We also asked, not for everything, but for some of the tests, we asked some other SDN controller results, just for reference to see where we are compared to other controllers.
Yeah, generally we did that where we saw feature sets that were similar, where we could do the same thing on ODL that we could do on another controller.
Exactly.
And as Luis said, it was more for reference rather than comparison necessarily.
Exactly. And finally, there is a set of recommendations. After doing this test, this effort, we realized ourselves, OpenDaylight, that there is some things we can do, not like very strong thing, but we can do things actually to improve the performance of the OpenDaylight. So those we will add in the report. So the last thing I'm going to comment is that these results you're going to see in this presentation are temporary, are just, we are working on this particular report, so we're going to be publishing all that. So just consider this as a preview of the results. You want to continue, or? Well, this is just a summary of the different. We haven't prepared this very much.
We just got the results pretty recently. So.
Yeah.
I can go ahead and walk through at least this first part, and then maybe we'll switch off again. So here's a beginning. This is a protocol summary. The top got cut off, so I'll repeat that part. But we did some OpenFlow tests. We did end-to-end performance, and we did southbound performance tests. We did netcomp tests. We did some northbound performance, some southbound scale tests, a southbound performance, and end performance for netconf. For our OVSDB project, we did a southbound scale test. And for BGP, we did a data ingest performance and data advertised performance. Obviously, I'm just reading these off, but we're going to talk more about what actually those tests include here in a second. For PCEP, we did an LSP read performance and LSP update performance. So I'll go into the next slide, which is the test environment here. So for the first setup, we had a Intel Xeon CPU, E5 2690. We had 40 cores, 128 gigs of RAM. We ran all these tests on Ubuntu. The network really wasn't used in most of these tests because they were running over local communication over loopback, so the network cards didn't really factor into the tests. The JVMs we were using for this was Oracle, and 8 gigs of Java heap with the default garbage collector. So this is our first test environment that we ran. Almost all of these tests we ran in both environments. So there are a few where there's exceptions, but OpenFlow tests and netcomp tests we ran in both environments, for example. The second test environment was a dual CPU Xeon, a little bit newer processor, E5 2600 V3. These tests were run on Fedora, Fedora 23, and they used, most of them used the loopback as well, except the OVSDB scale tests actually used the network interface, but it was only to connect to other exact replica systems that had test tools on them. They didn't actually have ODL on them. So JVM for that was OpenJDK, so it's a little bit different from the last test environment. We had 8 gigs of Java heap and a default garbage collector as well. Do you want to go ahead and do the OpenFlow end-to-end performance?
Yeah, why not? So, yeah, so this first test OpenFlow end-to-end performance, fortunately, yeah, hopefully, is
it's too bad. It's really hard to see, but
yeah. So this test, I don't know, you can read there, is a real end-to-end test where we configure 100K flows, use a test tool to inject the 100K flows in the controller, And then we wait for confirmation in the controller that the flow has been programmed. Different controllers have different ways to tell you, like this flow has been programmed. We will go through that. Then what we do, once they are programmed, we just remove and then wait again for confirmation. And then again, there is a step-by-step guide if anybody wants to reproduce this test. So this is very realistic scenario where you have some application on top of OpenDaylight, and you need to program a bunch of flows in a given time for any particular situation. So these are the numbers that we got, provisional number, as I said before, for the different things. Something I need to explain in OpenFlow plugin, in OpenFlow OpenDaylight, is that we have two plugins. The one that we release in Verilion, which is the one you see on top, and then there is a new plugin that is also, you can also enable that in Verilion. I mean, you have this traction in the wiki, but it's not enabled by default. And the reason is because we are still testing more this new plugin, and the plan is to release it in Boron, and that's why we had that there in Boron. We wanted to also, the reason to develop this new plugin in OpenDaylight was precisely because of performance and stability. We wanted to have this the new development. And because of that, we also included in this report. So this is a little bit to expect in the next release Boron in OpenDaylight. So as you can see there, the results show that for flow at, the first one, is actually how fast you can program your controller. Regardless of your network, how fast you can program your controller using REST interface, which is most of the people use to program the controller. So you can see there that Verilion plugin is 2K flows per second, the same as Boron plugin. Onos seems faster there. And then Flatlight is around the same as OpenDaylight, 2,000 flows per second, okay? The second metric is time to program the switch. So this is a time between you start your test, start pushing flows, 100K flows, and then everything gets programmed into the network, right? So that time, you can see, is also, well, it's going to be the same, 53 or 54 seconds in the case of the Flatlight and the OpenDaylight. And then the Onos there is kind of changed. We did a few tests, and then depending, it was very constant at the controller rate, but then switch programming rate was a little bit variation there. This is what we saw in our test. Well, I don't know if I need to explain the difference between this controller. OpenDaylight obviously is our controller. Ono is very similar to OpenDaylight in terms of, it's a rich controller with application as well. And then Flatlight is an OpenFlow light version of a controller. The last one, probably, the confirmation time. Some controllers like OpenDaylight, I don't know if they have some kind of confirmation. So in the case of OpenDaylight, we use statistics. We just ask the switch about the flows, about the flow configuration, and also flow statistics. And we use that as a confirmation that the flow has been programmed. In the case of Onos, for instance, what we use is something that there is a straight confirmation. So when you program in the northbound, there is a straight confirmation flow has been added. So different kind of confirmation, but still the same concept. So what we saw there is that Verilion plugin, for instance, to confirm the flows, it takes kind of between 23 and 143, depending on the amount of switches, depending on the network. The Boron plugin, and this is the most interesting that we are developing the Boron plugin, is very stable in the statistics. So you can see there that is between between 7 and 10 seconds, or with less than 10 seconds, no matter which topology, you get all your flows confirmed. So that was precisely the reason for this plugin, like have very stable statistics collection. Onos, again, it has also needs more time in general to confirm flows. And then Flatlight, because it's very light kind of controller, we didn't find a way to confirm flows. So you still need to go to the switch or whatever you had there and then pull the flows from there.
And something to mention about Floodlight is that it doesn't have have security for the flows in a sense. I can't get the word. Basically, you can encrypt the communication between Floodlight and the switch, whereas ONOS and OpenDaylight, that's actually a feature that So all these numbers are with that included.
So there is more security, obviously, in the ONOS and OpenDaylight, and that security also slows down a little bit the performance in this controller, obviously. All right. We can come back to any result if there are questions after this presentation. So this is only between Beryllium and Boron plugin in OpenDaylight, and this is to show something interesting. OpenDaylight support not only flow-by-flow programming, but it also support batch programming. So what is batch programming? Batch programming is that you have a REST interface, and instead of programming one flow per flow, you have the possibility, the REST API allows you to do that, to put many flows in one single request. So if you do that actually, and you see there is 200 flows in one REST call, you see your number multiply more or less per five times. So this is also something interesting. If you are writing applications on top of OpenDaylight, you can actually do that. You can accumulate flows in the simple request, and then you get 5 times more performance. And that is shown in this picture.
And we didn't show that for ONOS because as far as we could see, there wasn't a feature to do batch flow programming yet. I think it's on the list of things that they're planning to add, but as of now, that wasn't something we could test with ONOS.
Yeah, and that's why this is only OpenDaylight. And then again, you can see the only difference between the old and the new, especially the Boron, is the stability, again, the stability for the data collection, the stability for the statistics and for the flow confirmation. It's way better in the Boron. So this is more like end-to-end from northbound down to the switch. Now, this is another test that is purely southbound. So how we did the southbound test is also a very realistic scenario. We configure, again, 100K flows in the OpenDayflow network. After that, we restart the network. And restart the network means restart your switches. When you restart a switch, all the flows disappear. And then the expectation is the controller needs to reprogram the entire network. So it needs to program all the flow that has been programmed previously. So again, we restart the network, we wait until we get the confirmation that all the flows are reprogrammed. And there is a step-by-step guide also, if anybody want to check on how to do this test. So what are the results here for the southbound? Well, for Beryllium plugin, there is a flow add switch rate between 10 and 20,000 flows per second. And there is a confirmation time that varies from 160 to 204 seconds. So this is the result. For a Boron plugin in OpenDaylight again, we have a very constant rate of 10K, regardless of any topology. So it's very, very constant all the time. And look, the interesting thing is that you get also very stable collection or confirmation time, which is between 7 and 10 seconds, no matter which topology. For ONOS, we have flow at switch rate. Also, for this particular use case, we found that ONOS is kind of variation here between 1 and 14 flows per second. Some flows were missing. I don't know. And then the flow confirmation time is around 60 and 64 seconds. This is what we found. For flat light is a little bit like our Beryllium plugin, so around between 10 and 20K flows per second programming the network, and then 100K flows confirmation time. Oh yeah, we don't have API. Yeah, the same as for the other test. I need to mention that for ONOS, we are at least the test I did was a release candidate because there was no release. Probably in the final paper, we're going to try to use the final release. So they can say maybe something is not full.
Yeah, most of our testing was with the SR2, I believe it was.
Yeah.
I think what's that? Oh, Falcon, yes, sorry.
Yeah, it was Falcon release candidate, yeah.
I did do some with the release candidate, and the results were pretty similar, but we haven't replicated that in our second environment, so we didn't release those numbers.
Yeah. So anyway, these are the game provisional numbers, and we, yes? Sorry, say again? Yes, yes, yes. Yeah, so this is the OBS, and this is all the tests are done in the same environment, yes. Yeah. But we can get to the more questions for this later, yes. So yeah, you can answer.
I was just going to say, can we hold the questions till the end because we have a lot of material to get through, and we just want to make sure we get.
Yes, yeah. Let the question for because this is going to get. But we did tests with different kind of switches, and I didn't put all the results here because there is out of tables. But there is a wiki we can pull out later and see all the results in table. Yeah, the test is done with Mininet, and we try 15, we try 32, we try 64, we try different combination of switches. So let's go to netconf. So you want to do this one, or I should still explain? So yeah, the first step is netconf northbound. So netconf northbound, we support with two kinds of netconf interface in OpenDaylight. One is in northbound to be able to program OpenDaylight using netconf, and the other one is southbound. So for the northbound, we run this test. This test, what happens is that you can see here, the OpenDaylight start with simple model for netconf, and then we use external netconf client with push a lot of L2 fib entries, which is L2 fib is just a MAC address entry in the data store using netconf interface. The client measures so what we are measuring here is between the first request until the last is received. And then there is a step to guide how this actually works. And there is also this diagram, you cannot see very clear here, but yeah, there is the netconf client is pushing requests into the OpenDaylight netconf interface. These requests go to the data store configuration, and then this is confirmed with a commit. And this test, as you can see, is how fast, this is to test more or less, or to measure how fast you can actually configure your OpenDaylight using netconf interface. So by doing that, these are the figures that we get. So Beryllium release for single, again, we can do single or batching kind of requests. So if we use single programming, we get 7,000, like you can see here, 7,000 entries, MAC entries per second. If we use, in the case of TCP, if you use SSH security on, this is exactly the same expectation. So things is going to get a little bit down because of this extra security. And in that case, you get 6.6K entries, L2 entries per second. If we repeat the test, and now because our netconf interface also support batching, so we can get more than one entry per request. In that case, if we use 100 entries per netconf request, what we get is 42K entries per second, or 32.5 entries per second. Okay. So here is what is the southbound. So the northbound of OpenDaylight is used for programming OpenDaylight. The southbound is to program netconf devices, netconf servers. So in this second test, what we're going to be doing is, you can see here, there is a config pusher application in OpenDaylight that is going to be just connecting. Well, the way it works is this tool. We start this tool, and this tool generates some configuration for the OpenDaylight to scale, like a number of devices. And then we check in OpenDaylight that all the devices are effectively connected. It's just a scale test to see how many netconf devices we support in OpenDaylight. That's it. And there is a step-to-step for the production. So the figure that we got is this one. So device connected via TCP is 28,000 devices. And then devices connected via SSH with security, obviously less, is 14,000, half of them. Southbound performance. So southbound performance, OpenDaylight mounts, again, the same tool. We use, actually, no, in this case, it's just one device, a simulated device. And now there is a small ODL application triggers a netconf notification stream for new mount point. Simulated device starts sending routes with a certain number of prefixes. Application waits until notifications have been processed. So what we get there is that Beryllium release for, again, if we use single prefix per netconf notification, we get until 10,000 prefixes we can learn from the network. So this is information notification that we get from the network. The same if we repeat with SSH, is going to be a little less, so 9.8 thousand prefixes per second. Now, if we batch, and now we use notification with 10 prefixes in netconf, then we get 20,000 prefixes and then 16,000 prefixes per second. So almost we double the throughput or the performance by batching. So more things, netconf end-to-end performance. So this test is done end-to-end is because in the previous test was only southbound. So we have an application within, I know you realize here, we have an application in OpenDaylight that is actually exercising all the tests towards the real device outside. But this one is really end-to-end. You can see there is a REST client outside OpenDaylight. This is trying to program via REST the netconf device. So OpenDaylight mounts a simulated netconf device. External REST client starts sending prefixes via RESTconf. OpenDaylight application has transformed this to the device, and then the REST client waits for full confirmation of the operation. So what are the numbers there? So for this test, single prefix, again, REST interface provides single and batching kind of programming. For the single prefix, we get 3,000 prefix per second. If in case of SSH, we get 2,300 per second. For 50 prefixes, when we batch these requests, we get much more. We get 85 prefixes per second and then 61K prefixes per second. So it's OVSDB.
Yeah, so I'll go ahead and cover this one. So for OVSDB scale tests, this actually tests just the southbound. So there's a southbound plugin for OVSDB that connects to an OVS switch. This test basically has a controller sitting there and it has multiple identical systems as what the controller is running on. It runs Mininet on those systems and it connects to the controller and basically scales as high as Mininet will scale on those servers in order to get, in this test, there were only 4 servers doing this, so it was like around 600 or so was what I was able to get up to on Mininet before it started freezing. And essentially, it would connect back to the controller. It basically sets up what are nodes in the OVSDB southbound topology. And so this is a scale test that tests how many nodes you can get to. Basically, we got up to 1,800 bridges, but I don't know, the scale of this is actually a limitation of the test tools and how many actual systems that you can run Mininet on, for example. So this is not the actual maximum number, but this is at least the scale we can prove we can get to, at least as of now. So there's also Docker tests of this in progress, which runs Dockerized versions of OVS, but that's actually not ready yet. So this is the scale test we have for now.
Sure. For BGP, we have also BGP data because, BGP, our protocol is not only prefixes, but it's also support links, support flow specs, a bunch of things. So in this step, what we're going to be doing is OpenDaylight to connect to a BGP tool. You can see in the picture, or maybe not very well. And then BGP tool send 1 million updates single prefix to the OpenDaylight. We wait until the million updates are present, and you can see them in OpenDaylight. And then we disconnect the BGP tool and wait until all prefixes are removed from OpenDaylight. Okay? So for this kind of tests, in Beryllium release, we see the prefix add in OpenDaylight learning rate is 16K prefixes per second. For delete, if someone deletes externally, if we reset the connection, we get 23 prefixes per second in OpenDaylight. Now, there is another test we did for data advertise. So we support like learning, but also advertisement of prefixes. So in this case, OpenDaylight connect to the BGP tool. We need a tool for this. And then we use REST and Java application to populate there are 2 ways, actually, to populate the prefixes in the controller. One is using REST, and the other is using a Java application. When we populate all this, we restart the BGP connection and wait until all prefixes are learned by the BGP tool. Then we delete all the prefixes, and then we make sure that all the prefixes are clear. So this is a multi-step kind of test to show how fast we advertise prefixes to an external BGP peer. So with all this, the Beryllium release, again, If we use REST to populate the ODL RIF or a routing database, with single preface request, again, we can do 200 prefixes per second. If we populate the OpenDaylight with 100K, sorry. Yeah. So if we use Java, and then the next one, the same, it can be done in 6,000 prefixes per second. Now, there is a rate there, and the 100K preface request rate in the first case is 2K prefixes per second. So, okay, let me see. 100K preface per second, sorry, this is when you batch. So let me go back. When you use REST, you have two possibilities, single preface or batching. When you do single preface, you actually 200 per second. When you do batching, it's 10 times more, 2,000 preface per second. When you use a Java application internally in the controller, obviously you are not using REST, so it's much faster. And then regardless of single or 100, you can program at 6,000 prefaces per second because you are internally in OpenDaylight. So the next step was after reconnect the BGP tool. So we reset the BGP tool and reconnect, and then there is a prefix rate for this particular tool, and this is 20K prefixes per second after reconnect. And then after we remove the tool, in this test what we do is to remove all the prefixes in the OpenDaylight. So the fact that we remove everything in OpenDaylight in one call, it needs to send all these updates very quickly to the device. And this is where you see the delete rate of 15K prefixes per second. Okay? Finally, PSEP. So PSEP is this protocol to configure and monitor tunnels, MPLS tunnels. In this test, we have a PCC tool again, called PCC mock. The PCC connects to the OpenDaylight. The OpenDaylight in this case is the PCE entity of the PSEP protocol. The PCC tool sends information for 65,000 tunnels, and then we wait for the 65,000 tunnels are present in the OpenDaylight. There is a step-to-step guide there. So if we do this test, we get a real rate, tunnel real rate of 4.6K tunnel per second. This is using only one PCC. So let's see, this is only one router. In the case that we have 512 router or 512 PCC clients, the real rate is 4K tunnels per second. It doesn't change too much. So this is for reading. There is an update performance. No? I mean, the controller can be used to update your tunnel information. So in this case, we are using a tool called the same tool, PCC mock, connected to the OpenDaylight. And now we use a REST tool called updater PI to send the tunnel updates. Okay? We wait until the 65,000 tunnels are updated in the PCC tool, and then there is the next. And this is the result. So for Beryllium, we have update rate for one client, 1.8K tunnel per second. And if we want to update in a 5012 client network, we get 1.9K tunnel per second. Performance recommendation.
So we learned essentially while doing this test that batching obviously improves performance. We saw that in OpenFlow, and we also saw that in Netcomp southbound. So that's a performance recommendation if you're writing an app on top of one of these controllers or OpenDaylight, you basically want to use batching. By default, OpenDaylight persists configuration data, and so this can impact performance. Some controllers don't persist data, but essentially we recommend that you use an SSD if you're gonna try and push performance. And if you don't need persistence, disable it, and you'll get better performance as well. Or you could run some of the stuff where persistence resides on like a RAM disk or something along those lines.
I think we are done. Okay, so now let me put back the presentation. We can go through any question we have on any of the test. Let me go back. Okay, I don't know, you. Okay, you hand over the microphone, yes.
So I noticed that in general, batching gave you, an order of magnitude better performance often. There was one of those cases where it was only twice.
Yes,
Can you-
it's not really well explained here, but sometimes it's not only one case actually. If you see the result for batching, sometimes maybe multiply by 100 the number of requests. It doesn't give you a strike 100 because you are limited actually by the plugin. It gives you more performance, but not a strike a multiplier number of the batching. So for instance, I can show you some example of the batching here. Like here is only 5 times. Like when we do batching for exactly 200, you say 200 flow per request, that's 200 more. But then the difference that you get when you do the batching is actually five times. You get 5 times more. Mm-hmm. And why is this? Because you still need to account for processing internally, how you process the multi requests and that kind of things. So yeah, it's a good observation, but I think it's natural that you get.
And when I referred to twice, I mean, it really was only twice.
Yes, I don't know which there was twice, but
Are you talking about the netconf results?
Yeah, you're going through so many, it was hard to keep track.
Yeah.
I did notice that one was, I mean, if all of them were twice, you think it's no big deal, but it was odd that that one was not as accelerated.
Yeah, this one, for instance, is twice as well. We do 10 more. We do 10 times in a preface, and then we get 20. I mean, these are just empiric results. I mean, I don't know exactly, I'm not a software architect, so I don't know exactly why this is like this, but I think it makes sense because, I mean, you need, when you are sending more than one request, this needs to be processes as well. That takes some time, so you don't get a strike the 20 times, right? Plus, you have some overall limit in the way you can process your request.
Okay. I think in the future, as we do this testing more, we'll probably consider testing different batch sizes to see how performance scales based on the batches. So,
yeah, that was one of the things I was going to mention. You notice that we did 200, our batch for OpenFlow between the application and the controller was 200. That's an arbitrary number. You can do as many or as few in a batch that you want. And note that that was only in the northbound between the application and the controller. We had as a footnote on that last slide that you can actually batch those flow mods between the controller and the device in OpenFlow 1.5. Okay, we don't support OpenFlow 1.5 yet. We're still on 1.3, and that doesn't support batching between the controller and the device. So we expect to get significant performance improvements at that batching as well.
Some more questions.
2 questions. The first is the performance numbers that you've given. Were those with OpenDaylight with persistence enabled or disabled?
that was with persistence disabled.
Okay. Yes.
On environment too, yeah, the numbers that you saw. It also was with an SSD involved.
Yes.
And putting the journal and the snapshots on a RAM drive, so basically memory.
Were any of these also done in a sharded environment?
In
Cluster. Did you do any of these with clusters as well?
No. These tests are all single
So
instance.
we're actually working pretty hard on trying to get those tests, but that's something that we expect to do in the next few sort of.
We didn't explain this clear, but all this that we are doing is single instance. Mm-hmm. And we got the question on whether we're going to get the same kind of test for cluster. And it's probably next release. So by bottom release, we're going to try to do the same report, white paper, or whatever, and we're going to be showing the cluster numbers.
And for the test where you were comparing Beryllium, the Boron plugin, Onos, and Floodlight.
Yes.
For the flows that you were writing, were they random flows, or were there any redundancy in any of the flows that you were writing?
So these flows were built by a Python script, and the way this is iterating. So you have like I think it's IP flows, the way it works. So you are putting just regular, it's one prefix only, and then you just iterate on the IP address. That's it. And then the Python script, what it's doing is spreading this. You had different switches. We did a test with different switches, 8, 16, 32, 64. Mm-hmm. It's spreading the load into the different switches. 100K. If you have more switches, you get less, but if you have less switches, you have more per switch. That's the kind of test we did.
The numbers were pretty consistent across if you had 15 switches or 31 or 63. They didn't change much depending on the spread of. Yeah, I don't know if we have those called out in there.
Yeah, this is the test, not that you were mentioning. Yeah, this is the test that we put 100K flows, and then we wait for the network to.
There was one with Ono's had flows missing. That was the one I was thinking
Well,
about.
this again, I mean, this was a test where you restart your entire network, and then you expect everything to be programmed. And yeah, for some reason, we did this test a few times. Using the release candidate again, I had to say that we need to repeat this test when the Falcon is full release. But using release candidate, what was available last week at the time we were testing, we got some flows were missing after we restart the entire network. I mean, that's what we saw, so I don't know. I mean, we repeat this test several times, and we use 2 environments. So it's not like this test was run one, and maybe it was one-time failure. No, we did this a few times. Yeah.
Is there one location on the website that I can go and get a list of all the tests? I'm going to /view, and it's not really showing me anything. It says page not found. Is there like...
I don't know if we have a list of all the tests at once. We have different pages that have each set of tests, like the net console listed in certain places.
Yeah, but that means I've got to go back through your slides and go look up each one of the individual ones. Just note for the future, it would be nice to have a single spot where I can go and look at, okay, here are all the tests we've been doing. Oh, that looks interesting. Let me check that one out instead of having to search back through all your slides and find the detailed links.
Yeah.
Well,
So
that's a good comment. I think that as we release our white paper, we're probably going to make sure that that's all sorted out. Let's go over pre-release release of the numbers that we've been getting, and the white paper should come. Put it on the web. Sure.
Yeah.
It's on the web. It's just, we should organize it better, but we'll work on that as part of our.
Hi. So in some of the tests you mentioned you have like 1,400 or 2,800 devices. These are all software devices and with loopback, or they are actually sitting on different devices with traffic going across NIC to a different device?
They're all on loopback. And
They're all on loopback?
Yeah, and they're simulated devices, I believe.
They're all simulated?
Yes.
Okay.
Yeah.
Yeah. Okay, and I have another question. Do you have any, so this is all OV switch without the DPDK, these results?
Yes, there's no DPDK installed on any of the switches as of now.
Yeah. This is regular mininet, so anybody can actually try. This is very easy to reproduce. Any of these tests cannot take more than, maybe 30 minutes, no less, to do it, because it's all using very, very normal tools and nothing really, yeah.
Hey, just a quick question going back to your actual environment, your continuous integration environment setup. And I don't know if you're going to talk about, I know you had mentioned it in your intro, I don't know if you're going to talk about it later, if there's going to be something going on later, but what exactly, what's the architecture behind all that? Are you guys using Jenkins to kick off jobs, or are you using, what's the actual software that you're using to drive these tests? I mean, I know you got JUnit up there. I saw references to the robot framework and stuff like that. So
I can briefly explain. I didn't want to spend time. I have a full-blown presentation for how the system test works in OpenDaylight. So I can explain to you later after if you are interested, because it's a full presentation. But very quickly, we are using Jenkins. For all that is building code, we are using Jenkins. All that is build test, distribution check, auto-release is still Jenkins. And then all that is feature test, cluster test, system test, in general, SSB test, we use Robot Framework, for your question.
And just a note on the environment itself. Right now we're on a public cloud, but we actually have them building a private cloud so that we can do more interesting things with our CI environment. And we're looking at the possibility of adding like a rack of physical switches where we can do performance testing and things of that sort.
I have 2 questions. First question is it that the clustering is not very stable, that's why you haven't done the test, or is it that you haven't got time to do the tests?
So the cluster is very new. So far we know is HA, or high availability, seems to work okay. But we haven't got the time really to go and run all these performance tests that we are run today. And also, the question is also because it's very new. If we start to do tests and something doesn't work the way it should be, we need some time to. So in order to do a good white paper and present result, we probably need to wait one more release. Because also when we start testing, that we haven't started yet. If you see also in our CI test, all the performance tests we do today are single instance. So first we need to start testing, and that is going to happen in Boron release, the performance for the cluster. And second, we're going to fix. When we see issues during Boron cycle, whatever performance bottleneck thing that we find during the test, we need to fix. So that by Boron time is really the time where we're going to use these results.
I would just say that I know that Luis has been working on this quite a bit, but we have all of our function tests that run regularly on OpenDaylight single instance.
Yeah.
We're moving all of those over to do a sharded or 3-node cluster or something along those lines. And we're doing that right now, but those we feel like are more important, and then we're going to move on to the performance tests after that. So we need to make sure that we have a good release process before we get to that state.
Yeah.
But it's in the works.
I think the other question was, you mentioned that all your tests, you don't have persistency, you're not storing things. Is that the same case with ONOS and Floodlight?
So ONOS, for what we tested, doesn't persist. So we wanted to have the same scenario. We didn't know how to enable persistence in ONOS in that case, writing in the hard disk all the flow configuration. So what happened is when we started to do these tests, OpenDaylight persists so that when you restart, you get all your flows like there. Because of that, we are spending a lot of time writing in the hard disk. The moment we use RAM disk, or the moment you use SSD, or the moment we disable persistence, any of these things you could do, this is what you get the same performance numbers as the other controllers because of the hard disk writing.
Okay, so I guess it's good comparison. In both cases, there is no persistence.
We wanted to get this as fair as possible.
We were trying to get it basically as fair as possible across all three of the controllers. We didn't want to run up the score by doing something that...
Is there a roadmap for your containerized testing? You had mentioned you were using Docker, but I don't know if the tests are immature or inconclusive at this point.
I don't have a roadmap per se. I'm working right now on actually producing something similar to that, sort of a plan. Most of the Dockerized container testing that at least I plan on doing is with OVSDB, OVSDB projects and OpenDaylight, although I'd love to sort of expand that to include OpenFlow and some other projects that use OVS. But I don't have a roadmap right now, but it's something to expect here in the future in the next month or so.
So Docker is very interesting for two things, use cases, test cases. One is for controller cluster. So instead of spin VM, you spin Docker is much more effective. And the same you mentioned, for scalability, OVSDB or some other test that they can run the tool, the device can run in a Docker. That is also very good. So that's why we are spending some time to investigate how we can do this with Docker.
Yeah, we run into a lot of, on the scale side, we run into a lot of resource limitations as far as trying to scale to 2,000 nodes, for example.
It's also,
you can do it.
Sorry, I remember, infrastructure. I mean, we have some issue with the existing infrastructure to spin Docker.
In the public cloud, it's really difficult.
Cloud.
Yeah. So when we get our private cloud up, we'll be able to spin up Docker instances, which should allow us to do some more of these scale tests. It's also the case if we can get physical hardware to do this type of work, we'll obviously be able to use Docker to scale out as well. So,
two questions here. Hello?
Oh, yes.
One is about the NetConf result, 28,000. It's based on the setup 1 or setup 2?
Let's go there.
We did the tests in both environments. So both setups, we did NetConf tests.
Similar result?
They were pretty similar, yeah. I mean, I don't have the numbers in front of me, but they were within, I probably 10%.
Southbound, you are interested, or northbound? Which NetConf?
NetConf southbound.
Southbound, yeah. So this is the test, yeah. Southbound test is this one that you see here. And I think we used two setups for this test as well. And this is the summary of the results.
And like I said, I don't remember exactly what the difference is, but I think they're within 10% of each other in each environment.
So if we want to improve the number, what we can do? How to improve the number?
Oh, how do you improve it?
Yes.
Well, so there's a couple things that I'd like to just point out. That, at least for the NetConf test, we didn't disable persistence. So I don't know if it's storing anything on the disk, but it's possible we could improve performance by doing that. We also didn't test with the SSD in either of the environments. So there are some things that you could do off the top of my head and tune the system. Would probably be good. Turn off all the power saving stuff, and then also do like a deadline scheduler, for example. Yeah. But Yeah, I'm not an expert in network. Neither of us, I don't think, are. But if we had our netcom people here, I'm sure we could probably give you a better answer.
Yeah.
Okay. So second question 2 is about any test for the hybrid netconf and OpenFlow and BGP together.
Oh yeah, so this we discussed as well when we were doing this kind of paper, can we do really a combination of plugins? And the reason is we didn't have time. We didn't have time, so for now, it's just plugging a specific test. Hopefully by next release, we could do something that is more on that line, like using a combination of plugins. The thing is, if you use a combination of plugins, you are not testing the plugin anymore. You're probably testing the application that connects the two plugins together. And that is where the thing changes. But it's a very interesting test anyway, and we probably try to get that for the next release as well.
I have 2 questions.
Yes.
One question is, in your test platform, you have 40 cores. I don't know how you leverage these cores to improve performance.
Say again?
What was the question?
In your test platform, you have 40 cores, okay? How OpenDaylight leverages these cores to improve performance?
Oh, that's a tough question.
What is it?
He said you have 40 cores. On one of the test environments, you have 40 cores. The other one, we had 72 cores, actually.
The cores.
Yeah. And you're saying, how do we leverage those in OpenDaylight to improve performance? Or how do we leverage? What's that? Yeah, I don't think that we're doing a good job of leveraging. I mean, I think that when
Or maybe describe the VMs for Mininet, because they're all running on the same box and you're looping back, right? All of that's running on a box, right? So the cores are being leveraged across the test environment.
Yeah, I don't know how to answer it. Do you have a good answer like that?
Yeah, how to what?
I think the question is OpenDaylight
Yeah, because
is OpenDaylight using, in the controller itself, all of these cores and somehow improving performance? And I think the answer to that is no. We're using them for the other test tools and stuff. That's why we need so many cores for the test. But OpenDaylight itself isn't going to work drastically better with 40 cores than 72, or the opposite or something. It's 8 cores or something are probably the most we can make use of realistically.
And then maybe talk about the state of the CPUs during the tests, right?
Yeah, probably
as
we
far
need
as being
to.
Saturated.
Well, here's the thing. One of the things that was done partially was some profiling that happened during these tests to try to see how the CPU and network and other things were utilized. But we didn't have a chance to do that across our environments, so those aren't things that we've included because we haven't reproduced them. And so we don't have good information based on what we're doing with these tests to sort of answer that question. But
so that's true. Today we are running these tests, but we are not really monitoring the CPU while we are testing. And
but
maybe
I think
something
in the future, I think we will do profiling.
We should profile and see the CPU and memory usage through this test. Yeah.
One comment about a trend I'm hearing, and this not really a question, but make sure you're not gaming your tests. I mean, yes, there are ways you can improve your numbers, but don't do something that no one would ever do in real life just to improve the numbers. I mean, yes, I hear that removing persistence makes it faster. I don't know, if no one would ever do that in real life, maybe there's not too much point in testing that. So just keep that in mind.
Yeah.
It's a good point to keep in mind. I think we talked quite a bit about this during our run up to the testing and what we should actually test and how we should do it. So I think it's a good comment. I think we tried really hard not to do that, but.
Yeah, we specifically talked about that, David, and it seemed as though persistence, again, couldn't find it in the other controllers, and while it makes recovery, if the controller goes down a little bit longer, it's something that the application can do. So there are certainly scenarios where not having persistence does make sense in a real-world environment. And because of that, in the apples-to-apples that we were trying to do from a comparison, it was the opposite of gaming, but actually trying to find something that was as comparable as possible.
My another question is, I don't know, this performance data is bad or good or best. In my opinion, I think OpenDaylight performance is worse because in China, our customer Tencent thinks OpenFlow performance is very bad.
Yeah, I'm not sure actually what your customer has in China, but.
Yeah, I mean, so our biggest learning out of this was the fact that because we use persistence by default, and we had spinning disks in our test environment, we were getting bad numbers.
Yeah.
Right. In one environment, we were getting great numbers. One environment, we weren't getting great numbers. And we came to realize that it was an SSD in one versus the other. Right. So persistence still on, but with an SSD, it's much, much faster. So Tencent, our learning is that, again, because we use persistence, because we're writing stuff to disk, it should be a fast disk. Right. If you're going to write to disk, it should be a fast disk. If you're not going to write to disk and not use performance, or persistence rather, it doesn't really matter. But that was a key difference, and it was an order of magnitude.
Yeah, that's definitely the case. And I would also say that Tencent recently joined OpenDaylight, and I think that the emphasis there is actually to share the data that they have, the performance that doesn't work for them. And I think that we can definitely help them get better performance. And then the second thing is we're going to go back and look at how we can make it perform well enough in their use case.
Actually,
because I think the use case really matters quite a bit.
Yeah, we selected this use case because we thought it's kind of real use cases, programming flows northbound and restarting your network to see just about performance. But I believe some other people might have other use cases with their customer or by themselves. And if any of these test cases we are performing bad, we want to know. I mean, we want to know and contact the community, explain the use case, because I cannot know. I mean, you say, it's bad performance, in which scenario, in which situation, which software we are using, what is your use case. But if you tell all the information, we can help. Definitely we can help. We are taking very seriously performance and scalability. So if anybody come to the community and say, in this particular use case, using this software, this doesn't perform, we will fix it.
Hi, so my question is, you had a comparison of beryllium versus boron, and boron seemed very good, like the switch program time, etc. So can you explain, I mean, now we're just starting off with boron, so the reason why we're seeing such good numbers, or is it going to be the same after, all the code freezes, etc.? So can you just explain that?
So you want to explain why we are showing the boron, or why?
I mean, the reason why we're getting good numbers with boron. It was 7 to 10 seconds.
So the reason for boron is we just redid the plugin. We use the same API, so applications shouldn't be impacted. But there was a work this work started in lithium, actually. I can tell a little bit of story of this. This work started in lithium. We started to work in a full-blown new OpenFlow implementation. And in lithium, there was no time to release it at all. And then we wait for beryllium. In beryllium, what happened that in the end, we didn't test it enough, and still there was some question with the application consuming. We need to migrate all the applications, so we didn't have time. So in beryllium, what we did is actually just benchmark this new plugin to make sure it's better than the other one, and just hold it to boron. And this is just, we did for the reason that we saw for two reasons, performance, and performance in terms of what you saw there, performance instead of programming a large network, but more especially stability. Stability, when you program a huge network, you're going to receive a lot of statistics for the network, a lot of information from the network. And to be able to handle that, you need to optimize your data collection. And I think this is what is shown here. It's very stable instead of data collection, and it's also that you get always almost the very fixed time to get information where everything is programmed when things change. So that's the main difference with the lithium plugin. Sorry, with the boron plugin.
Very good. We're out of time, so thank you very, very much, Louis and Marcus.
Here, I don't know if I can zoom in. Phil, how do you deal with this? How do you deal with this tool? In the Mac.
I don't. I just know my slides.
I know my slide, but the only thing is I don't know if the numbers are going to show later somehow. Yeah, maybe they do. That's okay. Yeah, that's fine. Yeah, I think I'm okay. Okay, let's get started. This is just, so yeah, a little bit of test story in OpenDaylight. So the first thing was, I don't know, unfortunately we cannot see very well, but in September 2013, as you can see there, we created something called the integration group in OpenDaylight. This was we created with the scope of doing distribution, assembly, like we need to put all the projects together. At that time, there were very few projects, along with doing some system tests. So we created a distribution, and then we do some system tests around that. That was the first milestone or first achievement regarding tests in OpenDaylight. The second thing that happened in this timeline is the hydrogen release. That was in February 2014. And as you can see there, in that first release of OpenDaylight, we managed to get some system tests in for OpenFlow, BTN, some applications that were there. And that was all. I remember 2 years ago, I was in this same ONS, and then some people presenting OpenDaylight for the first time, and then some people asked for performance number. At that time, obviously, we didn't have any performance number. And we said clearly that we will use future releases to do performance tests. Hello, so welcome everybody to this OpenDaylight mini summit. My name is Luis Gomez. I'm actually contributor committer of the integration group in OpenDaylight. I'm also part of the TSC and part of the board in OpenDaylight. And today we are here to present you will see for the first time some of the performance results for the OpenDaylight. I'm going to do a short introduction how we do tests in OpenDaylight, and then I'll hand over to my colleague here, Marcus. You can introduce yourself as well.
Hi, my name is Marcus Williams. I'm a network engineer at Intel. I'm on our SDN team. I work with the integration test group as well as a contributor, and I'm a committer on CPerf for OPNFV, which is Controller Performance Testing Group. That's me.
I'm going to adjust this, hold on a little bit. I'm going to see percentage because otherwise it's too small, so I cannot really. Or actually, you know what? Let's do like this. I'm going to, presentation mode, and then you can swap here, and I can explain on the, okay. That's better. Because that way I can see what's going on. Oh, actually, I don't know if I can see well. It's not like we can see very well. Yeah, the problem is, here is a little bit how the strategy for the test works in OpenDaylight. And as you can see here, you have all kind of triggers. We'll go very quickly. When you have code submit, someone put a new patch in the system, you have a verified build that run all the build tests. And after that, we do distribution check. The distribution is not broken. And we do auto-release test. The release is not broken either. All these things are happening in real time when you push a patch in the system. Now, when a committer merge a patch in the system, there is many more tests happening. Like you see here, there is, again, a build test. But there is also a distribution build. And then after you build the distribution, you get feature tests, you get cluster tests, and you also trigger a bunch of tests in the downstream. Because we have a dependency change in OpenDaylight. When there is a change in the upstream, you trigger also tests in the downstream to make sure you don't break anything. And finally, you see for auto-release, we also do feature tests, we do multi-feature tests. Every time there is a new release or temporary release, we do all this, and we do cluster tests. And then we have daily triggers as well. So we kind of run tests periodically. These tests take longer, obviously, and that's why we don't trigger them very often, but still daily. And these are the stability, what we said before, the SSP test, and also the multi-feature test. These are longer tests that are periodic. Now, all these results that you see here, they are all available. So this is all the point here. You can see these are the link for the different places where you can see all these results. And for all that is performance, we plot this kind of graph, so you can go there and actually see all these results. It's all available. Okay. So let's talk a little bit about tests in OpenDaylight in general, not just the performance number. So these are today all the different type of tests we have in OpenDaylight. As you can see here, these are all also important to know. You cannot see the title, but this is continuous integration test kind of test. And what is the difference between continuous integration and not continuous integration? Continuous integration means that all these tests are happening in real time. So whenever there is a new build, whenever we have a new merge in the system, there is a full strategy here. You launch these tests, and then you make sure there is no regression, things are working normal. So what kind of tests we have today? We have build tests, as every software development project. You have build tests running at build time, JUnit, because you use Java. And then we have something called single feature test, that you test your feature is still available when you do changes in your code. The second is the one that I mentioned before, the one we did is initially in integration group and now is handed over to projects, which is called the system test. And this is to test features, but also multi-feature. So we bring a feature, we test it like a black box system test. And then we also bring multi-feature with many features together, and we test the same feature and see there is no problem, there is no interference. The next one is what we talked about, the scalability, stability, scalability, and performance test, whatever you see there. That was introduced in Lithium, and we do that in continuous integration. And we do, the last one was the cluster test, data consistency and high availability. Those tests we do as well. These tests are all available, so I will explain that later here. The next was Helium release. That was around September 2014. And that was the moment that we introduced the first performance test. The first performance test we did the known C-bench test. It was kind of standardized test for OpenFlow. Like there was an open source tool from Flatlight people. And then this tool was actually injecting a lot of packaging, and then you measure the throughput in the southbound, and that was the kind of test we have.
Yeah, you measure the flow mods from the controller, and they're just dropping all packets.
Yeah. And then that was the only test we got at that time. Lithium release was actually the release where we got a lot more of the tests, what we called SSP. SSP in OpenDaylight was a term that we introduced at that time, and it's the meaning of that, and you know very well.
S3P is actually it's scalability, stability, security, and performance, yes.
Yeah. So Lithium release was the first release we introduced this SSP kind of test. At that time, we did only for OpenFlow. So we got the OpenFlow plugin, and then let's do a scalability test, let's do performance test all the way we know, and then do some scalability, stability test as well. So we did all that for the OpenFlow. And then Lithium release was also the first time we saw a cluster test in OpenDaylight. Very simple cluster test, only for data replication, but we got that in Lithium release. Finally, Beryllium release, this is the point, the first release we actually gonna publish performance number. OpenDaylight for the first time we're gonna publish performance number. And some of these numbers you will see through this presentation.